We've been asked to graph absolute value of x plus absolute value of y is equal to 1. Let me give you a hint and I'll want you to pause the video and think about it. So you must have come across this equation for a circle x squared plus y squared is equal to 1, and this equation represents a circle which has a radius of 1 and which is centered at the origin. So it represents this circle where all the points are 1 unit apart from the center, 0 comma 0. And you can think this is very similar to this equation as one might expect. So I'd want you to pause the video and come back. So hoping that you're back with a good intuition, let us go ahead and graph it. So what I like to do is I always like to make y the subject of the formula, subject of the equation, because ultimately I want to graph it as y as a function of x. We graph it in y and x axis, and y is always a function of x. So let me do that. Let me write it as absolute value of y is equal to 1 minus absolute value of x. And I might use some words like mod x to signify absolute value of x. Right? So mod x and absolute value of x are same for me. So mod y is equal to 1 minus mod x. Now, what does it mean for some number, say a, to be equal to modulus of the other number, absolute value of the other number? Well, it means that a is equal to either negative b or positive b, but we can still narrow down these cases depending on the value of b. If b is greater than or equal to 0, then we get a positive number for b. We actually open the absolute value sign with a positive value. Or if b is less than or equal to 0, we use the negative b version. And you should sit with this for a while and come back only when you're absolutely convinced with this idea, with this logic. Now let's apply the same logic over here. I'd like to rewrite mod y is equal to 1 minus mod x in a split version of the absolute value sign. So let me talk about this mod y, very similar in the case of b. So mod y I can compare with mod b, and I can rewrite the equation as either 1 minus mod x could have been equal to negative y, or 1 minus mod x could have been equal to positive y. These are the two cases that could have happened because there's a mod around y. So this or this could have happened, but we also can narrow down this case depending on the value of y, right? So I'll open my mod with a negative sign when y is less than 0. Or I'll call it y is less than or equal to 0, because when they are equal, when b is equal to 0 in this case, it doesn't really matter which definition you use. And for y is greater than or equal to 0, we'll have y is equal to 1 minus mod x. And now I think we are ready to graph it. Maybe I'll just make this y the subject of the formula again by multiplying both sides with a negative symbol. I'll rewrite both the equations. Y is equal to negative 1 minus mod x, or let me even simplify it. If I distribute negative 1 to both the terms, I'll rewrite it as negative 1 plus mod x, and the other equation becomes y is equal to it will be 1 minus mod x. I might not be consistent with the colors, but I hope you understand. Either this case or this case has to be satisfied. So now we can go ahead and graph it. So the first graph we'll have to do is y is equal to minus 1 plus mod x. To graph that, let me just graph mod x first. And y is equal to mod x graph, y is equal to mod x, is actually a kind of a combination of two graphs. Y is equal to x when x is positive, and y is equal to minus x when x is negative. So it will look something like this. Y is equal to x when you're on the positive x direction. Y is equal to minus x, a line with a slope of minus 1, when you're on the negative x direction. And now we'll have to shift all the points by 1 unit down, because from each of the x value I'm subtracting 1. So this whole graph would be shifted down 1 unit. So let me just graph that too. So this is the graph shifted down by a unit. This point would become -1. It'll be 0 comma -1, and you'll have this graph, but this only holds for the values of y given in the criteria. Let me rewrite the criteria too. Y is less than equal to 0 and y is greater than equal to 0. And you should always go back and think about where this criteria came from if you don't understand it. So this is applicable only when y is less than equal to 0. And which region would be that? Where the output is just negative. So it will just be this region, right? Where the output of the graph is negative. This curve would be applicable in that case. Well, let us graph the other equation. I think we are getting somewhere. It kind of looks like the bottom part of the semicircle. It's just in a diamond shape. So we're on the right track. So let me graph this other equation. Y is equal to minus absolute value of x plus 1. So y is equal to minus mod x. If I just graph y is equal to minus mod x, it will be the negative of this graph, y is equal to mod x. It will just be reflection of this graph along the x-axis because all the output values would be flipped. And if you're not convinced with any of these statements, you can always pause and think about it. So this is y is equal to minus mod x. Then all you have to do is just add 1 to it, right? So we'll have to add 1 to it. So finally we'll be getting, if I add 1 to all the points, I'll shift this graph 1 unit up, right? So this will look like this, shifted 1 unit up. Let me draw it. Let me do a better job at drawing this because this will be a final answer, right? And where is this applicable? It's only applicable for y values that are greater than or equal to 0. So just positive outputs. I'll just take positive outputs for the final curve. These are just the positive outputs. And see, now we are getting a graph very similar to a circle, but they're just straight lines. It's a diamond shaped curve. And immediately we see that it's not a function of y. And it should also have been evident from this definition because two values of y can work for a single value of x. You can sit and try that. So it's not a function of y, but we can just call it a relation, or we are just graphing this equation.